Hello everyone, today I'll talk about the solution to the problem find the length of the longest common prefix. In this problem we're given two sets of values. Those values are integers, but for all intents and purposes they might be considered as strings. We can create all the possible pairs of values, where the first one is from the first set, the second one is from the second set. Look at the longest common prefix in every pair and take the maximum over that. So the longest common prefix from among all those pairs. We have to find the length of that longest common prefix. And of course the main idea here is that we want to avoid looking at all those pairs. We want to do something smarter than looking at every pair separately, because that is going to be quadratic in the sizes of those two arrays. And we can use a data structure that's known as tree to solve this problem faster. That's because a tree in general allows us to take a set of words, some dictionary, and then it'll allow us to do some simple lookups, so simple manipulation, string matching, that will occur simultaneously over all the words in our dictionary. So, for instance, it'll allow us, in this problem, to take one of those sets, let's say this array 1, and create a tree of that in such a way that we can take a value from array 2 and compare it at the same time to all the values in array 1. But it's still not going to be that time consuming as if we were to do it just separately, all the values from array 1. Of course, a tree, as a reminder, is essentially a tree that starts with an empty string, and then in our case it'll go down by every possible digit to a new node, and so on. And so here we have a path of 0 then 1 reaching this node. That means that the string 0, 1 exists somewhere in our dictionary, or is a prefix of something in our dictionary. We can also mark a node to say that this is exactly the end of some word. So here we have a marked node corresponding to the string 0, 1. That means that we had a string 0, 1 in our dictionary. And so how do we look up for a single value from array 2 the longest common prefix, the longest common prefix that it has with anything from array 1? Well, it's very simple. We just have to traverse the tree built over array 1, going through the digits of the value that we had from array 2. That's because, let's say that our value in array 2 is something like 1, 2, 3, 4, 5. And in our tree we can go down the path of 1, then 2, then 3, and then we cannot go any further. That means that something started as 1, 2, 3. In fact, it had to end here, but it doesn't really matter. So with that thing, we have a longest common prefix of 3, length 3. And it's not possible to get a longest common prefix with anything else, because there is nothing that starts with 1, 2, 3, 4 in our tree corresponding to the whole of array 1. And that is the whole algorithm. So we're going to be using a standard boilerplate implementation of a tree. And now the solution will build a tree over all the values in array 1, treated them as strings. So essentially every node in our tree can have up to 10 children. And the index, of course, of a child is the difference between the ASCII value of the character and ASCII value of the letter 0. And now we'll remember the best longest common prefix, and now we find the longest common prefix of every value from array 2 with all the values in array 1 simultaneously. So we start at the root of our tree. We're going to be going through all the characters in our value from array 2. If at some point we fall off the tree, then we break. Otherwise, we know that we have reached a step deeper. So we look at the number of the current step. Maybe it's better than the best common prefix that we've found, so we'll remember it, and of course descend down the tree. And since we do that for all the values in array 2, and the tree is built over all the values in array 1, that will guarantee us that now the value in best is exactly this longest common prefix among all the pairs.